We're looking at logarithms, and a logarithm is defined as y equals log base a of x, and we're going to say that it implies this x equals a to the y. So when looking at a log, like let's say I wanted to look at log base 2 of 32, you're basically asking the question from this definition of an exponent here, how many powers of my base do I have? So how many powers of 2 is 32? So 2 to what power is 32? And this would be 5. Now we can see this by going back through the definition, and you would just look to see where's your x, where's your y, and where's your a. Clearly my x in this case is 32. So putting it in exponential form, which you'll be asked to do at times, you'll be asked to go from log form to exponential form and from exponential to log form. So my x is 32, my a, that's a 2, 32 equals 2, and then we were asked the question to what power, and of course we said, well, that was 2 to the 5th power is 32. This is called logarithmic form, this is called exponential form, and we'll look at several of these and see if we can figure out what the answer is. So if I do log base 5, let's say of 25, how many powers of 5 is 25? The answer to this would be 2. If I were to ask you what is log base 3 of 27, how many powers of 3 is 27? That would be 3. Log base 10 of, let's say, 1,000. How many powers of 10 is 1,000? That would be 3. Now this is also called a common logarithm. It's the one you'll see the log button for on your calculator. When it is written without its base here, that is understood to be log base 10. So I could have asked you log of 1,000, and this answer would be 3 because it's an understood log base 10. We're also going to be discussing log base e in just a few moments. All right, let's look at a couple more. Let's look at log base 2 of 1/2. Now I'm trying to figure out 2 to what power will give me 1/2. In order to get this fraction, that would mean a negative exponent. So this would actually equal 2 to the negative 1 would be 1/2. So log base 2 of 1/2 is negative 1. So let's carry that a little bit further. Log base 2 of 1/4. 2 to what power is a 4th? And this would equal negative 2. That's how we get that exponent, or that fraction with that exponent there. Let's look at log base 2 of 1. 2 to what power equals 1? This would be 0. What about log base 3 of 1? This would be 3 to what power equals 1? This would also be 0. We can make a generalization here after looking at a few of these, that log, at any base really, of 1 equals 0. All right, what we're going to do next is we're going to talk about these qualifiers here. This x is greater than 0, a is greater than 0, and a is not equal to 1, and figure out why those things exist. Let's try to look at, say, log base 2 of 0. And I have this qualifier that my x must be greater than 0. And let's figure out why. 2 to what power is 0? Oh, there's nothing I can raise 2. There's no power that I can raise 2 to get a 0. There's why that one little qualifier exists. And then my a needs to be greater than 0 so that my base isn't some negative base that I have to raise a power to. And let's see, if a, which is my base, were equal to 1, then I would have 1 raised to some power, which 1 raised to whatever power I want to put it to is still going to be 1, so that wouldn't make any sense with logarithms as well, and that's why we have these little qualifiers on here to get rid of the kind of nonsense, or we're going to get rid of those cases that may be undefined or have no place to exist. All right, we're going to define a natural log. And a natural log just means that it's log base e. So if I have natural log, or log base e, of let's just say e, this e is to an understood 1 power, so how many powers of e is that? That would be 1. Well, we use natural log quite a bit, and so we have a special notation for it. Instead of writing log base e every time, which we could, we write ln, which means natural log. So anytime you write this ln, what you really mean is log base e. And so log base e, natural log of e would be equal to 1. The natural log of e squared would be equal to 2, because it asks the question, how many powers of e do I have? Let's see, what is log base 2 of 2? That would equal 1. How many powers of 2 is that? Log base 3 of 3. That would also be equal to 1. So we have this generalization where we say that log base a of a equals 1. We've looked at these first two, what they call log properties or generalizations, and it just says the log at any base of 1 equals 0, and log base a of a equals 1. Let's look at this third one and see if we can see how that applies. Let's look at a few examples. Log base 2 of, let's say, 2 to the 5th. Well, log asks the question, how many powers of my base do I have? So 5. Log base 3 of, let's say, 3 squared. And how many powers of my base do I have? That would be 2. Oh, that's why they have this generalization, because it's actually asking how many powers of my base do I have, and in this particular case I have x. Okay, so it would equal x in that case. Let's do the natural log of e to the 3rd. This would equal 3. And there's our introduction to logarithms. We're going to do properties of logarithms in the next video.